Hello there, you beautiful people, and first of all, I commend your dedication for stepping up to take this optional lecture on useful Python maths functions. This kind of dedication to always find out more makes it very clear to me that you're going to do great in this course and in your future work as a Python programmer. Nice one. Now in this lecture, I'm going to share with you some things which you might use quite often if you do rather maths intensive or engineering related work with Python. These include things like rounding numbers, trigonometric functions, exponentials, logs, squaring numbers, cubing numbers, etc. Now for this kind of stuff, you'll need to use Python's math module. Feel free to check out the documentation for Python's math module for yourself in the Python docs like I showed you earlier. But in this lecture, I'm just going to cherry pick a few examples to give you a feel of what's possible. But there are many more things for you to explore and play with to see what you personally might find useful. By the end of this lecture, you'll have more of an idea of what Python has to offer maths-wise, and I'll also point you in the direction of a few more advanced libraries or modules for you to look at. We obviously have a lot to do, so I'm going to be going quite fast to fit it all in. Don't worry if I go too fast, just listen to the bits that are relevant to you and rewind them, otherwise just ignore me. Alright, let's go. So a common thing you might want to do in Python is to round numbers to the nearest integer. Now this is done using Python's built-in round function. So for example, if we have the number 2.1, by typing round 2.1, Python is going to round this number down and give us back the number 2. Just like that. Likewise, if we have the number 1.5, by typing round 1.5, Python is going to round this up to the next whole number, which is also the number 2. Something to notice here is the way that round has gone purple. This shows that it's a Python built-in function. It's just one of the basic standard functions that Python already comes with. But Python's basic math support is not all that powerful. So to use some more powerful abilities, we can import Python's math module, which is full of all sorts of functions and stuff in there. So here's a micro challenge for you. Using what we covered in the last few lectures, try to import the Python math module. So go ahead and pause the video now. Head over to your shell and import Python's math module in the same way that we imported the random module, and come back here to see how you did. So how did you get on? Did you manage it? Well, if you did something like this, you opened up your shell and you typed import math, and you pressed enter and got no errors, then fantastic, that was exactly it. Because we know the module is called math, all we had to do was type import and then math, okay? Because whatever the module name is, you put here. So brilliant. Now sometimes you only want Python to round up or round down to the nearest integer, regardless of the value you're rounding. So for example, if I just do the regular round of 1.5, because it ends in 0.5, it's going to round up, isn't it? But what if we wanted to force it down to 1? Well, for that, we could use some of the built-in, well, not built-in, but use some of the math module functions. So for example, if I just do round of 1.5, we're going to get 2. But if I do math.floor of 1.5, you can see it rounds it down to 1, because that's using the floor function inside the math module, and that will give us 1. Likewise, if I do, I don't know, math.ceil of 2.1, that's going to round up to 3. Ceil is short for ceiling, like the ceiling in a room. So instead of rounding down to 2, which it would normally do, like up here, it's rounded up to the next integer, which was 3. Along with having functions inside of it, Python's math module also has a few useful values already built in, such as pi and e, the exponential. So for example, if we type math.pi and press enter, we see that we get pi to quite a few decimal places. And likewise, if we do math.e, we're going to get the exponential to quite a few decimal places, which is useful because you don't have to type these up and, it saves you just a bit of work. Now, Python's math module also has standard trigonometric functions such as sine, cos, and tan, as well as inverse trigonometric functions such as arcsine, arccos, and arctan already built in and ready to go. But do bear in mind that these functions take numbers in radians and not degrees by default. So for example, we know that the sine of pi by 2 is 1, right? So if we type math.sine of math.pi divided by 2, we get 1 as expected, but notice the answer that comes out is a float. Likewise, if we type math.sine of pi, which is just math.pi, then we're going to get 0. or almost 0. As you can see, we get 1 times 10 to the minus 16, which is a very, very small number, but it isn't exactly 0. The reason it's not exactly 0 is because when we entered math.pi up here, that is only an approximation to pi. So to get this to be actually exactly 0, what we might want to do is do math.floor of math.sine of math.pi. So basically we take that number and put it in there, and that's going to round it down to 0 as expected. So likewise, we can use cosine, for example. We know that cosine of 0 is 1. So if we do math.cos of 0, we're going to get 1. And to show an example of taking the inverse of the sine function, we can do math.asine of 0, and we can see that we get 0 back. Likewise, if we do math.acos of 0, we get 1.5707, which is pi by 2, as expected. If you check on the cosine graph, that's what you need. We can also use the math library to find the hypotenuse of a right-angled triangle using the Pythagorean theorem. Now, as we know, the hypotenuse of a right-angled triangle, where A and B are the small sides, and then C is the hypotenuse, the long side, you can use the square root of A squared plus B squared. But for a right-angled triangle with short sides of lengths 3 and 4, the hypotenuse is 5. So we can check this by doing math.hypot 3 and 4. And we're going to get back 5, because 3 squared is 9, 4 squared is 16. Add those together, you get 25. Square root of 25 is 5. This function is also useful for finding resultant vectors in vector algebra as well. We can also square numbers and cube numbers in Python very easily using the math.pow function. So for example, if we want to get 2 to the power of 3, or 2 cubed, we can type math.pow of 2 to the power of 3, and that's going to give us back 8. We could alternatively, as a shortcut, we could do 2 times 3, and that's also going to give us 8, but as an integer instead of a float. So this is available without using or without importing the math module, and is a shortcut that's just generally built into Python. But you can see there's a difference in the variable type that comes out. So let's take another example. Let's say we wanted to find 9 squared. We could do math.pow of 9 to the power of 2. We're going to get 81.0, or we could do 9 star 2. We get 81 as an integer. You can also find the exponential of a number using the math.exp function. So for example, if we wanted e to the power of 2, we could just type math.exp 2, and that's going to give us 7.39, which if you type it in the calculator, you get the same thing. The same goes for natural logs. As we know, the natural log of an exponential always equal 1. So we can see this result when we type math.log of math.e as a constant. We're going to see 1 come out. So that works fine. But if you want the base 10 log or base 2 versions of log, you can use the log10 function, or sorry, the math.log10 function, or the math.log2 function, respectively. For example, if we do math.log10 of 1,000, what we're going to see is 3, because 10 to the power of 3 is 1,000. Likewise, if we do math.log2 of 8, we're going to get 3, because 2 to the power of 3 is 8. So there we have it. That was a really quick run through of some of the things that are available in the Python math library. Of course, you aren't expected to memorize any of this, and I'm not even expecting you to need to use most of it. Just use this lecture as a starting reference in the future if you ever need to do more mathematical things in Python. You've got it there for life. So one thing you should be able to take away from this lecture, however, is that Python is very capable of doing mathematical processes, and there is plenty of functions available for that kind of thing. If you want more in-depth stuff, you might want to check out the NumPy and SciPy libraries for more advanced functionality that is best suited for data analysis. But well done, you've survived the gauntlet and made it to the end of the numbers section of the course. In the next video, we're going to have a quick review of this section to make sure you've got all the concepts down, and then we'll move on to a quiz and coding challenge and stuff like that. So without further ado, I'll see you in the next video.